All right, here we go. Continuing on, we are going to look at partial sums and sums of infinite geometric series. So a sum that you just add up to a certain number of terms is called a partial sum. The partial sum of an infinite geometric series may approach a limiting value. So for example, if we look at this geometric series, 1/2, 1/4, 1/8, 1/16, the denominator is doubling. As I graph it, again, half, 0.75, 0.88, 0.94 approximately, you can see that we are approaching closer to 1. So we would say that as Sn appears to approach 1 as n increases. It's just going to get closer and closer and closer to that line. And then we also have a formula, so make sure you write this down on how to find sums of infinite geometric series. So that's what we have right here. A1 equals A1 over 1 minus R. Provided the absolute value of R is smaller than 1. If absolute value of R is greater than or equal to 1, the series has no sum. So let's take a look. Let's say we'll do 2 examples here. If I started at 1 and I wanted to go to infinity, let's say I had the series 5, 0.8 I minus 1. That'll be the first one, and then we're also going to do the series 1, negative 3/4 plus 9/16 minus 27/64 plus all the way to infinity. So we'll start with this one on the left here. Again, using my formula, fill in what I know. I know my first term is 5, and that my R is less than 1. It's 0.8. So I can plug this into my equation. S equals A1 over 1 minus R. S equals 5 over 1 minus 0.8, which means that this is 5 over 0.2. And when you do 5 divided by 0.2, you get an answer of 25. So the sum of this, again, it's going to be approaching 25. On the second example, okay, I see that my first term is 1. And now I have to figure out what R is. And it looks like to me R is negative 3/4, because again we have the alternating positives and negatives. That's how I know it's a negative. And so again, 1 divided by negative 3/4 is negative 3/4. You multiply 3 times negative 3 times negative 3, you get a 9. Multiply 4 by 4, you get 16. Keep going. So again, as I plug it into my equation, I have 1 over 1 minus negative 3/4. Again, minus a negative is really like adding. They cancel each other out. So this is 1 over 1 3/4, or 1.75. So when I do 1, let's call this 7 over 4. So if I do 1 divided by 7 over 4, I need to keep, change, and flip. So I get a final answer of 4/7. So the sum of this series is 4/7. Let's see here. One other example is like a pendulum. So a pendulum is released to swing freely. It travels 18 inches on the first swing, and then each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance of the pendulum swings? So again, that would be like saying, all right, our first term is 18. It's starting at 18, and it's only traveling 80%. which again would mean that my rate is 0.8. So if I plug into my equation, the sum of this infinite series is 18 over 1 minus 0.8, which equals 18 over 0.2. And then when you multiply that, you get an answer of 90. So the pendulum travels a total of 90 inches or 7.5 feet, 7 feet 6 inches. Last little bit we want to go over is writing repeating decimals as fractions. So let's say that we had the number 0.242424 continuing on forever. That would be like something like 24 multiplied by 0.01 plus 24 multiplied by 0.01 squared plus 24 multiplied by 0.01 to the third, and continuing on and on and on. So again, what do? I use my equation and I say, all right, A1 is 24, R is 0.01. So if I think about my equation, I'm going to say 24 and then I'm actually going to substitute 24.0 times 0.01, which is my first term. I'm going to actually multiply that out. So I get 0.24. So again, I'm looking right here. My first term is actually 0.24. So 0.24, and then again, 1 minus 0.01. 1 minus 0.01 is going to give me 0.24 over 0.99. And now I have to simplify. I'm going to say, all right, well, what I could do is I could move this decimal point over and move this decimal point. Again, that's multiplying by 100. So I have 24 over 99. And now I need to figure out, what do they have in common? Well, I think that 24 and 99 have a 3 in common. So I'm going to simplify by factoring out a 3. And I'm going to be left with 8 over 33. So we like to write repeating decimals as fractions because, again, you can't necessarily, if it repeats forever, you can't write that. You can't continue writing forever. But if you write your answer as a fraction, it means the same thing. And you can be, I guess it's more mathematically accurate because this means that the number will repeat forever.